Good morning, sir.
Morning, sir.
Good morning.
Good morning,
Morning,
sir.
sir.
सेवन थर्टी को people are not yet waking up. मार्च फर्स्ट से क्या हाल होगा तुम लोगों का?
पूरी क्लास सेटअप्स करेंगे।
अब सुनो, we dealt with moment of inertia of a solid sphere. We cut out a solid sphere from inside a solid sphere. Irido का problem किया है? Yes or no?
Yes, sir.
Yes, sir.
Now, one small thing before we proceed into something very important. If this is the axis and this is a thin rod rotating about this axis, the thin rod is rotating this way. It's not rotating this way. This way, I know you know the answer. ml square by
3.
3. Right? Here, just to make sure that you know that the axis, I'll make it. This is theta. M is the mass of this rod, L is the length of the rod. Will you try or should I discuss?
Sir, we'll try.
I'm waiting. Consider a small element dx at a distance of x. What will its distance from the axis be? X sine theta.
Yes.
Di will be equal to dm into x sine theta whole square. Sigma of mi xi square.
Yes, sir.
Sigma of mi xi square. Integral di mass per unit length into dx. X square sine square theta. Unitary method, mass per unit length into length. Least value of x is 0, maximum value of x is L. Mass per unit length sine square theta integral x square dx. 0 m sine square theta by L cube by 3 m L square by 3L sine square theta.
L L
तो L
square
चला
ना
जाएगा
L चला जाएगा नीचे
ना
से
नीचे भी L लिख
Denominator
दिया।
वाला है।
Cancel कर
Yes sir. Sir, I don't know if another method I use is correct, but like, can we resolve it and solve? Like, along
Here
this
it does
axis,
because the mass is
uniform, constant.
Near
mass is
answer.
not
Yes, sir.
constant, it becomes a problem.
Yes, sir. Okay, sir.
The traditional method you should know technically.
Okay, sir.
Sir, is this a problem or a result to be remembered?
This is just a problem.
So is there a way to approach this problem without using integration, like using parallel axis theorem or something?
नहीं. Parallel नहीं.
Okay.
Maximum you can resolve it along this direction. This will not give me anything. This will give me L
Yes,
prime.
sir. Same thing.
Resolve it and do it. But that applies only because the mass is constant.
See uniform.
Uniform. Moment of inertia of a hollow sphere.
Two mr square by 3.
2 by 3 mr
Two
square.
by 3 mass.
Solid sphere.
2 by 5
By
by
5
5
mr
mass.
square.
Sphere.
So क्या
Already said hollow sphere.
Hollow sphere. Bolo.
2 by 3 mr cube.
M r squared by 3. 2 m r squared by 5.
2 mass square.
Hollow sphere.
2
2
m
by
r
3
squared
mass.
by 3.
Hollow sphere.
2 m r squared by 3.
Disk about an axis passing through the center.
R square by 2.
M r squared
M
by
R
2.
square by 2.
Ring.
mr square.
Something very important is being covered. Please concentrate, focus. If you are feeling sleepy, slap yourself once. If that doesn't work, ask your mom, dad, somebody to do the needful. They'll do it wholeheartedly. Something important is being dealt with. Please pay attention. We have learned how to take a torque equation in the start before we even came into this. Right?
Yes.
This is a thin rod of length L and mass M. Length L, mass M. Connected by two strings to the ceiling. If this string snaps, find the tension in this string at that instant.
And then it snaps.
If this string snaps, Find the tension in the other string at that instance. Firstly, did you understand the question?
Yes, sir.
Yes.
Now listen, hereafter for the next 5 or 6 lectures, we'll be dealing with only 3 things. Firstly, translational dynamic equation, rotational dynamic equation, and constraint relations. First one, what did I say?
Translational
Translational
dynamic.
dynamic.
Dynamic equation.
Second,
Rotational
dynamic.
dynamic.
third,
Constraint
Constraint
relation.
every problem will be going
Constraint
on.
equation.
This forms 60% of this chapter. Applying these is the toughest task. Technically speaking, if I tell you these 3 things, this subtopic is over. But applications will go on for 6 to 7 lectures. You can understand the catching. So learn it properly. First point, translational dynamic equation we learned in the chapter Newton's laws. Vector sum of all the forces. This is mg. Vector sum of all the forces. mg minus t is m into a. A will be the acceleration of which point of the body?
Center of
Center of mass.
Center of mass.
Center of mass. So vector summation of all the forces is mass into acceleration. Acceleration is the acceleration of center of mass of the body.
Yes, sir.
Yes, sir. Yes, sir.
This was what we have learned for the past 1 year. Then comes the torque equation. I take the torque about point P. Why? Because tension is passing through that point.
0.
Tension will give me 0 torque. This tension has gone. Only mg is left over. mg into L by 2
L by
is equal to I into alpha. Rotational dynamic equation. Net total torque should be equal to I into alpha.
Yes.
F equal to ma ka replica. We have done this. Torque is equal to I into alpha.
Yes.
Now, this is my first equation. Second equation I will further simplify. mgl by 2. You took torque about which axis?
P.
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 So moment of inertia also should be about P.
Yes,
Yes, sir.
Out.
L square by 3.
Ml square by 3.
Into alpha. M and M will get cancelled. L and L will get cancelled. Alpha is 3g by 2l. This is my second equation. Translational dynamic equation, rotational dynamic equation. Now constraints. These 2 end points of the string should have the same velocity or acceleration along the length of the string. This end point and this end point should have the same acceleration. Yes or no?
Yes, sir. Yes, sir.
Along
Yes.
the length of the string.
Yes.
Now, इसका acceleration कितना है?
0.
0.
0. So acceleration of the point P,
0.
0.
acceleration of point P with respect to center of mass plus acceleration of center of mass with respect to ground is acceleration of point P with respect to ground. Acceleration of point P with respect to center of mass plus acceleration of center of mass with respect to ground will be acceleration of point P with respect to ground. Do you agree with that?
Yes.
Yes.
About the center of mass, the body has an angular acceleration of alpha.
Yes, sir.
Yes.
So acceleration of point P with respect to center of mass will be L by 2 alpha. Do you agree with that? R alpha.
Yes.
R alpha.
Yes, sir.
This is R alpha with respect to center of mass. So L by 2 alpha is the acceleration of point P with respect to center of mass. L by 2 alpha. Upward direction. Acceleration of center of mass with respect to ground is ACM minus ACM. क्यों भाई साहब माइनस क्यों लिया है? I have taken everything in the upward direction positive, downward direction negative. मुझे रिवर्स में लेना है, ले लो, कोई दिक्कत नहीं. Minus L by 2 alpha plus ACM is the acceleration of point P with respect to ground, which should be the same as the acceleration of this point, 0. Translational dynamic equation, rotational dynamic equation, constraint relations. Constraint relations, how did you apply? You found out the acceleration of the point P along the length of the string and you equated it to this point. Acceleration of point P with respect to center of mass plus acceleration of center of mass with respect to ground is acceleration of point P with respect to ground. ACM is equal to L by 2 alpha. This is my third equation.
Sir, shouldn't
What
alpha
did they
also,
ask you to calculate T? Pardon?
sir, shouldn't alpha also come in acceleration of center of mass with respect to ground?
Center of mass का acceleration में alpha कहाँ आएगा? It's a point mass.
Okay.
Now what did they ask you? They asked you the value of T. So now what will you do? Mg minus T is M into ACM. I will substitute L by 2 alpha. Alpha I will substitute 3G by 2L. Right? This will become T is equal to Mg by 4. Acceleration of point P with respect to center of mass is R alpha. Point P is going about the center of mass. R alpha, circular motion, right? Body is having an angular acceleration of alpha. So acceleration of point P with respect to center of mass is L by 2 alpha. Plus acceleration of center of mass with respect to ground is acceleration of point P with respect to ground, which I should equate to this point, that is 0. So the tension in the string at this instant is mg by 4. Have a look at all three equations carefully. The most important thing about this problem is yet to come. Take it down. Subtopics name torque equations. Subtopic name torque equations. Somebody wants to know downward, you have taken negative. मुझे जो direction चाहिए वो ले सकते. मुझे downward positive चाहिए ले. But don't take both upwards and downwards positive or negative. Acceleration of point P with respect to ground should be same as the acceleration of the other end of the string. Right?
So इसमें point P has no acceleration perpendicular to the string. No?
Acceleration of this point with respect to ground should be the same as the acceleration of this point along the length of the string. So acceleration of this point with respect to center of mass plus acceleration of center of mass with respect to ground is acceleration of this point with respect to ground.
Sir, over here angular acceleration will be about point P or C. मतलब वो समझा नहीं कि उधर C के about.
Rigid body theorem.
अच्छा हाँ, सब जगह same होगा.
About any point will be the same. Now listen, all of you have a look at that boy's route. What did he say? Will alpha be about T or C? Watch out for this. Suppose you didn't want to take the constraints this way. All of you pay attention. Do I have your attention?
Yes, sir.
Yes, sir.
Acceleration of C with respect to P plus acceleration of P with respect to ground is acceleration of C with respect to ground. Do you agree with this?
Yes.
Acceleration of C with respect to P plus acceleration of P with respect to ground will be acceleration of C with respect to ground.
Yes, sir.
ऐसा भी कर सकता हूँ. अब देख लो, acceleration of C with respect to P will be L by 2 alpha downwards.
Yes, sir.
Alpha is in this direction. Acceleration of C with respect to P is L by 2 alpha in the downward direction. Yes or no?
Yes.
Acceleration of P with respect to ground is 0. Should be acceleration of C with respect to ground, which is ACM. So alpha I took about C here. Alpha I took about P here. Same answer आया?
Yes, sir.
So can you explain this again? What did you use over here, like this theorem?
Relative velocity.
अच्छा, हाँ.
Relative na angular velocity.
Acceleration.
Acceleration.
Relative acceleration.
सेकंड वाले में the one you have written now, उसमें जो when we have taken alpha, we are considering it to be about point P, right? Over here, P से C का distance. Okay.
Acceleration of C with respect to P
Okay.
will be the same alpha, same
Yes, sir.
omega.
Yes.
You stand on any point of the body, omega will be the same. Alpha will
हाँ
be the
sir,
same.
alpha भी.
Yes.
Sir, magnitude wise only, right? Omega will be same magnitude wise, right?
नहीं, सब same ही रहेगा.
सारे particles
अरे भाई, you are standing in America, you are standing in India. Direction of Earth's rotation different रहेगा तुम दोनों की.
No, sir.
Sun rises always in the east, whether you are in America or in India.
Yes, sir. Got it.
Direction will be the same.
Okay, sir.
So, but in both cases, we are getting acceleration of center of mass in opposite directions, right?
कुछ भी. Why?
Sir,
यही वैसे
acceleration
with
of
direction ही तो
Value.
लिया है ACM.
AC
वेक्टर ही
is in
ऐड
the
किया है.
downward direction. AC is in the downward direction. This dynamic equation. You had no choice. एक बार ये dynamic equation लिख लिया, तो acceleration of center of mass must be in the downward direction. इस equation के वजह से. Problem के बीच में you cannot change your convention. अगर आपको ACM ऊपर लेना है, मुझे कोई दिक्कत नहीं. बस इस equation change करो. P minus mg is m into ACM लिखो. I'm okay with it. In the last step, if you have taken the wrong direction, you will get ACM negative. ऐसा कैसा हो सकता है? ACM थोड़ी ऊपर रहेगा, मुझे कोई दिक्कत नहीं. आपको ACM upwards लेना ही है. Just write this equation as T minus mg is m into ACM. यहाँ पर instead of minus, I'll put plus. Right? And you'll get the correct answer.
Sir, but how can you define a direction of rotation in free space? You can define an axis, but उसके बाद clockwise, anti-clockwise doesn't make sense at all, ना? क्योंकि both are relative to each other.
That depends on the point in what direction it is moving.
But you can't define something in free space, ना पर, because
Nothing can be defined in free space. My absolute motion itself is not defined. So वो यहाँ किस तरह is interrupting your problem?
no, like when you said कि the direction of rotation doesn't change if like on Earth, if you're in the USA or you're
With
in India.
respect to any point on the rigid body, direction of rotation will be the same.
Okay.
And any
With respect
part
to a
on
point on
any
the
part of Earth will be rotating only in one direction.
Yes, sir. हाँ, बराबर.
Can you explain the equation mgl by 2 because ms square by 3 alpha?
mg L by 2. I took the torque about point P.
Yes, sir.
This tension is passing through that point.
Yes, sir.
Mg into the perpendicular distance is L by 2
Yes, sir.
equal to I alpha. Torque I took about point P. Moment of inertia should be about point P.
Yes, sir.
ml square by 3 into alpha.
Yes, sir.
Sir, acceleration of P with respect to ground is 0 because it's attached to a rigid support, right?
Right. Acceleration of point P with respect to ground along the length of the string should be equal to this. A जो भी value है, that time this should have the same acceleration along the length of the string.
Okay, sir. Got it.
Can I rub the board?
Yes.
Yes, sir.
So that
Sir,
L
one
by
minute.
2 alpha is the angular acceleration, right?
Tangential.
Can.
You people are now asking me what is AT यार हद होती है circular motion जब बच्चे थे सीख लिया अभी पूछ रहे हो what is AT is equal to R alpha अब मैं circular motion थोड़ी पढ़ाऊंगा यार 5 महीने हो गए इतने टेस्ट ले लिए उस पर tangential acceleration is R alpha is difficult to recognize.
Sir, what if there's a
Not done.
special case where the string doesn't remain taut if there is enough weight on the other side?
Which of you make this? ये तो सीख लो पहले इस पर रिसर्च कर रहे हो. Can I rub the board?
Yes, sir.
Now listen. Even till now I did not teach you which all points you can take the torque about. I'm taking torque about point P. You agreed and you took the torque. I want to now take the torque about point C.
Yes.
I should be able to take the torque. First, translational dynamic equation mg minus T is m into ACM. This is my first equation. Are we okay with this?
Yes.
Rotational dynamic equation. Here I am taking the torque about
Center of mass.
center of mass. Torque about center of mass. mg is passing through center of mass. What will be the torque about center of mass?
0.
Now this will be T into L by 2 is equal to I into alpha. How much is I?
ml square by 3.
ml square by 12.
12.
I took the torque
2 by
about
12.
center of mass. About
Yeah.
center of mass, what is I? ml
Square by
square by
12. L square by 12.
Now this will become 6. L will get cancelled. T is equal to ml by 6 into alpha is my second equation. Third equation constraint relations are the same. Acceleration of point P with respect to center of mass plus acceleration of center of mass with respect to ground is acceleration of point P with respect to ground. This is L by 2 alpha minus ACM should be equal to 0. Right? Here alpha is 6T by ml. Now I'll go to the first equation mg minus T. mg minus T is m into ACM is L by 2 alpha. Alpha is how much? 6T by ml. ml will go, this will become 3T. mg is equal to 4T. T is equal to mg by 4. Is this the same answer that you are expecting?
Yes,
Yes,
sir.
sir.
So by what I have taught till now, I have made you feel that you can take the torque about any point of your choice, which actually is wrong. But this way we do, you will remember this all your life. First take it down. Here there is no torque due to a couple. I do not have two equal forces. First place, first wording itself is lost. So you don't tell me I can take torque about any axis and I'll get the same torque. I will not. I am not getting the same. This is not a couple. So technically, I should take torque about only one particular point. I can take torque about any point. That is altogether a different system. I didn't equate two torques here, right? If it were a couple, I can take torque about two axes and equate. Both the torques will be the same. Here, both the torques are not the same. Here, how much I got? Torque T into L by 2, this value. Previous case, the torque taken. Both are not the same. Alpha is the same for both. I is not the same. So the torque about center of mass and torque about point P are not the same. They will be same only for
Couple.
torque due to a couple. Don't mess up with these ideas. Here torque equation may this torque and torque about point P are not equal. In this problem, I am not trying to make you feel that torque about both are the same. They are not the same. Be crystal clear. Alpha is the same. It should be the same rigid body. I is not the same. So how will the torque be the same? And neither am I expecting torque to be same. This is not a couple. Only thing I showed to you that you can take the torque either about point P or either about C.
Sir, there will be a pseudo force acting on point C, right? Because it is accelerating in downwards direction. So won't it affect the torque equation?
If you put a pseudo force through C, what is the torque due to that pseudo force about C?
0. Sir, 0, 0. Sorry, yes, sir.
So, but we are doing everything in ground frame, so why will pseudo force come into it?
He's just trying to confuse us. Don't fall for his trap. Can I rub the board?
Yes.
No. What have you done here? You have taken torque about P, you have taken torque about C, and you got the same answer. So what have you achieved? You are misleading us to believe that you can take the torque about any point and get the answer. We will not. I'll first take an example. First, we'll see that we will not get. Then we will analyze why we didn't get. Then we will know which all points about which you can take the torque, and you'll remember that all you, right? I just tilted this rod by an angle theta. By an angle theta. Same rod. Question is the same. Here constraints will be a bit messy. Carefully listen. First of all, what are the dynamics you have learned? Translational dynamic equation.
Rotational dynamic
Dynamic
equation of
equation,
constraint.
relation.
Firstly, free body diagram draw कर लो. This is mg, this is t. So translational dynamic equation mg minus t is m into a. A is what?
ACM.
Acceleration.
Acceleration of center of mass.
Mass.
Yes. Direction did you take?
Downward.
Your this equation confined my option. Thereafter, in between the problem, don't change the direction. Right?
Yes.
Now, rotational dynamic equation. Talk about point P. mg into what is this perpendicular distance?
L by
L
2.
sin
By
L
2
cos
cos theta is I into alpha. mg into L by 2 cos theta is ml square by 12 into alpha. Sorry, 3 into alpha. You could talk about point P.
P.
Yes, sir.
Yes.
M and M will go, 1 L will go. Alpha is 3g cos theta by 2L. Is my calculation correct?
Yes, sir.
Translational rotational equations are not difficult. Right? Do not copy this till I tell you.
Yes.
What did I say?
Do not
Do
copy.
not copy
copy
this.
this.
Tell us.
Now, constraint relations देख लो. थोड़ा constraint relations are difficult to handle here. Acceleration of point P with respect to center of mass will be R alpha perpendicular to R. Anytime that will be the case. R alpha perpendicular to R. If I take this, R alpha perpendicular to R. Yes or no?
Yes, sir.
Yes, sir.
So this is R alpha. I should take the vector summation of this and this. That I will have to resolve along the length of the string to equate it to this point.
Yes.
All of you keep your mind, eyes and heart open. Acceleration of this particular point P with respect to center of mass plus acceleration of center of mass with respect to ground is acceleration of point P with respect to ground. But then that resultant I will have to resolve along the length of the string to equate it to 0. Yes or no?
Yes. Yes.
Yes, sir.
Instead of taking the resultant and resolving, can I resolve and take the resultant?
Yes, sir. That will
Take
be
this
better.
along y-axis, take this along y-axis, take this along y-axis, along the length of the string. If this is theta, this is theta.
Yes.
So acceleration of point P with respect to center of mass is L by 2 alpha cos theta in the upward direction. Do you all agree with that? Acceleration of center of mass is minus A in the downward direction. This should be 0. This is my third equation. Translational rotational dynamic equation constraint relation. Constraint relation means there is a key catch. L by 2 alpha and ACM, the resultant जो लेंगे आप, that you will have to resolve along the length of the string and equate it to 0. Instead of taking the resultant and resolving, I will resolve and take the resultant along the length of the string. Are we okay with that?
Yes, sir.
Yes, sir.
So L by 2 alpha cos theta minus A is equal to 0. 1, 2, 3 should give me the tension T. Yes or no?
Yes.
ध्यान से सुनिए. Do not copy that. Now I will take the torque about center of mass. Are you okay with that?
Yes, sir.
Yes, sir.
Talk about COM. Translational dynamic equation. Now you people will tell me.
mg minus
T
t
minus
is
T
equal
is
to m
equal
into
to
ACM.
M into ACM. First equation. Are we okay with that?
Yes, sir.
Yes,
Sir.
Now talk about center of mass.
Mg into 0 plus.
Mg into 0. I leave it. The other force.
T into L by 2.
L by 2 into T. Into L by 2.
L by 2 cos theta, no?
But cos
L by
theta.
2 cos
T
theta.
into L by 2 cos theta.
Into this perpendicular distance is L
L
by
by 2
2
cos theta.
cos theta. Do everybody agree with that?
Yes.
Yes.
Yes, sir.
Yes, sir.
Will be equal to I alpha ml
Yes.
square
12
by
by
12 into alpha.
That.
One L will go, this will become 6. Alpha is 6t by ml into cos theta. This is my second equation. So far, so good? Yes or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
Third equation is the constraint, same thing. A is equal to L by 2 alpha cos theta. Third equation is the constraint. Right? Constraint will not change whether you have taken the torque about C or P.
Yes, sir.
Yes.
Now my requirement is T. So substitute this A here. Mg minus T is M into L by 2 cos theta into alpha. Alpha is how much? 6t by ml into cos theta. Is my simplification correct?
Yes, sir.
Yes.
In the place of A, I put L by 2 alpha cos theta. L by 2 alpha cos theta. Alpha, I substituted this. ml will go, this will become 3. mg minus T is
3t cos square theta.
3t cos square theta.
T cos square theta. Right? Take T to the right. 1 plus 3 cos square theta is equal to mg. Bring this 1 plus cos square theta to the denominator. I will get T. Yes or no?
Yes.
Yes.
Yes, sir.
Now listen carefully. In your notes, what you will do is write from here till here. Right? And then in your rough notes, do the simplification using 1, 2, and 3. Verify if you are getting the same answer or no. Did you understand the instruction? In
Yes,
your
Yes,
notes,
sir.
you will write from here till here. And in your rough notes, do the simplification using 1, 2, and 3. Previous problem, both procedures, you got the same answer.
same answer.
Yes.
By default, a student should assume that they will get the same answer. Solve and see and tell me. First,
Sir, नहीं
take
आ
this
रहा. नहीं आ रहा.
First, take this down.
वो लेफ्ट पार्ट नहीं कॉपी करता.
तुम नहीं आ रहा है बोल दोगे, बाकी लोग नहीं करेंगे. My purpose will be served. You destroy my purpose. नहीं आएगा, मुझे पता है. करने तो दो एक बार उनको बाकी. They will remember that all throughout their life.
So we don't have to copy the left part, right?
Do not copy the left part right now. Copy only the right part. Do the simplification of the left part equations in a rough sheet. Verify if you are getting the same answer or not. Somebody is asking, should we use moment of inertia of the inclined rod? See the axis about which it is rotating. You have taken I about this. I about this. The rod is rotating this way. Inclined rod le loge. Angle between them is perpendicular no yaar. Right? Inclined rod tabhi loge when it is rotating this way. Right?
Sir.
The rod is rotating in the plane of the bow. Bolo.
Yes, sir. Sir, technically on the right hand side, the top equation L by 2 alpha cos theta minus A, उसमें minus L by 2 cos alpha cos theta plus A होना चाहिए ना technically. Like answer same आएगा but sign convention के हिसाब से.
क्या फिर से बोलो.
सर सब राइट हैंड साइड में जो टॉप इक्वेशन 3 लिखा है 3 ऊपर ऊपर उसके ऊपर. हाँ यस सर. इसमें साइन कन्वेंशन के हिसाब से माइनस L by 2
cos theta is in the upward direction.
तो माइनस
in
आना
the downward direction. L by 2 alpha cos theta is in the upward direction.
यस सर. तो हमने अपवर्ड को माइनस लिया था ना.
सर ने उल्टा
यार आप लोगों को make you stand upside down. अब क्या फर्क पड़ेगा तुम्हें?
सर आंसर नहीं आएगा बट सर मैं बस वो टेक्निकली देख कंफर्म करना.
Can take any side as positive.
समझा ना, बस -1 से मल्टीप्लाई किया उसको डॉट क्या.
हाँ.
Yes, sir.
Not done, sir.
Do not copy the left part. In a rough sheet, do the simplification and confirm to yourself that you are not getting the same answer. Important lesson life. Important life lesson. Committing a mistake is not a mistake. Not learning from the mistake is a blunder. We have committed a mistake in this. First, confirm that you will not get the same answer. Now, analyzing why the mistake has been committed and rectifying is a necessity and must. That's when we learn.
So just wait for 1 minute.
Wait for 2 minutes. Don't worry. Tanmay Jha, please switch on your mic and ask me your doubt. Your statement doesn't make sense to me.
Yes, as in like the circular acceleration, why don't we take it for the center of mass? Like we take the translational acceleration, but it also has the angular acceleration, right?
Did anybody understand his doubt? Help me out.
It's like the resultant acceleration should be translational plus the angular acceleration.
Is that what he's saying?
Yes, sir.
Omega.
Which point?
A is the net acceleration of the
Yes,
center of
sir.
mass. A is the net acceleration of the center of mass. Right? I have shown to you in the previous case. If you want to take acceleration of center of mass with respect to point P, it will be L by 2 alpha plus acceleration of point P. I'll get the acceleration of center of mass with respect to ground, which is the resultant, which is A.
Yes, sir.
Previous example, I have done the reverse and I showed to you. So A is the resultant acceleration of all motions on it.
Okay, sir. Yeah. Thank you.
Now, first of all, is everybody convinced that the first procedure is not giving me the answer?
Yes, sir. Not
Yes,
giving the
sir.
answer.
Yes,
Sir,
sir.
but how do we
Now,
know which answer is correct?
you
Yes,
really
sir.
think I'll leave the class here and walk away?
No, sir.
Now, then keep your mic off if you want to learn. Right? Listen. Firstly, how by default are you assuming that this will be the correct answer and this will be the wrong answer? Any one of them can be the correct answer, right? Listen, fundamentally as a thumb rule, in general, they will tell you a general rule that take the torque always about center of mass of the body. You will never falter. But we will have necessities to deviate from center of mass in complex problems. Firstly, what went wrong in this particular procedure? I will rub the right hand side part of the board.
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
Where we have gone wrong is point P is accelerating here. My torque equation is wrong. क्या बोल रहे हो? Point P कैसा accelerate कर सकता है? Horizontal direction में accelerate कर सकता है? Horizontal direction में accelerate कर सकता है? Watch out for this. In the constraints, you have taken acceleration of point P with respect to ground along y direction to be 0. X direction. L by 2 alpha sine theta. Acceleration of point P with respect to center of mass along x-axis plus acceleration of center of mass with respect to the ground along x-axis is acceleration of point P with respect to ground along x-axis. Do you agree with this?
Yes.
Yes, sir.
Yes, sir.
Acceleration of point P with respect to center of mass along x-axis is L by 2 alpha sine theta minus I cap.
Yes.
Yes.
Acceleration of center of mass with respect to the ground along x-axis
Zero.
is 0. Why?
No external force. Horizontal.
There is no
Initial
horizontal
direction में.
external force at all.
Yes.
So acceleration of point P with respect to the ground along x-axis is this. तो क्या दिक्कत है यार आपका? Let it have.
Yes.
If I take the torque about point P, I must introduce a pseudo force of M into L by 2 alpha sine theta. This is pseudo force. Point P is accelerating. Y direction क्यों नहीं लोगे यार? Y direction का acceleration is 0. X axis में it is accelerating to the left. Pseudo force on this should be taken to the right. Mass of the body into acceleration of point P, opposite to the direction of acceleration of point P. This pseudo force went missing for you in the previous torque equation. When you took the torque equation, you took only because of mg. mg into L by 2 cos theta. This is giving me clockwise. Right?
Yes.
This is giving me clockwise, but even the pseudo force is giving me clockwise plus m L by 2 alpha sine theta into the perpendicular distance. This is the perpendicular distance when you extend the line of action of pseudo force.
Yes.
The perpendicular distance will be how much?
L by 2 cos.
L by 2
cos.
sine theta.
Sine theta.
This is theta, this is L by 2. This perpendicular
L by 2
distance
sine
is L by 2 sine theta. Agreed?
Yes, sir.
I'm taking torque about point P. Extend this. The perpendicular distance is. This is theta. This is not theta. This is theta. So L by 2 sine theta. Yes or no?
Yes.
Equate to I into alpha. This is ml square by 3 into alpha. This will be my second equation. This will be my third equation. Now simplify and tell me, are you getting the same P or not?
Sir, should we write this in notebook?
Yes. From here you will write. Taking torque about point P. Torque about P. This procedure is by taking the torque about point P. Simplify for T and tell me if you are getting the correct answer or not. I am waiting for you. Point P is accelerating to the left. If you are taking the torque about point P, you have to introduce a pseudo force on the center of mass of the body, which will be equal to mass of the body into acceleration of point P, opposite to the direction of acceleration of the point P. If it is an accelerating point, pseudo force is mandatory when you take the torque about that point.
So do we have to add the constraint relation?
Constraint relation यही तो रहेगा, इसमें तो change क्या होगा? Write down the constraint relation as equation 3. Simplify. Tell me if you are getting the same answer for T. I'm waiting for you people.
So,
Hmm.
so this pseudo force we took was in x direction. So the perpendicular distance from P, why are we taking it as sine theta? That becomes the
What
y.
do you want to take? Extend the line of action of the force. Drop a perpendicular on it from the point about which you are taking the torque. So this perpendicular distance will be how much? This is L by 2, this is theta, this is L by 2 sine theta.
Yes, sorry.
Extend the line of action of the force. Drop a perpendicular on it from the point about which you are taking the torque.
Sir, why didn't we take pseudo force on point P only?
पहले ये solve करके answer बोलो, step by step we will go.
Sir, also the pseudo force acts on center of mass, right?
First solve this and tell me the answer step by
अच्छा,
step we will
sorry.
go. आप लोगों को एक बार बोलने से समझ में नहीं आता है. Does it take so long?
Yes, sir.
Yes, done.
सिंप्लीफिकेशन हुआ है?
सर ये हो गया सर सिंपलीफिकेशन।
Yes.
mgl by 2 cos theta is equal to ml square by 3 minus ml square by 4.
Sir, m can get cancelled out.
Pardon?
M can get cancelled out.
ml square by 3. I'm taking this to the right. ml square by 4 alpha sin square theta. Now m gets cancelled out. One L will get cancelled. Alpha is how much?
6g cos theta by 4 minus
Upon
3
1
sin
minus
squared
3
theta.
sin.
The 4L minus 3L sin theta.
Yeah.
4 minus 3 sin square theta whole alpha.
Yes.
सर
Did I go
6G
down
cos
here?
theta आता है।
6g cos theta.
Yes, sir. 6g
न्यूमरेटर में
cos.
6G
Yes,
cos
sir.
theta आता है।
Alpha का?
Yes, sir.
Yes, sir. Numerator में
6g
6.
cos
4
theta by
minus 3
L.
sin
4L
square
minus
3L into
3L
sin
sin
square
square theta.
Yes.
4L
बंदा बोलो ना यार.
4L
4L
minus 3L sin squared theta.
Yes, sir.
L sin square. This alpha I'll have to substitute here. mg minus t is m into a is L by 2 cos theta into alpha. Alpha is this. Alpha is 6g cos theta by 4L minus 3L sin square theta. Is that correct?
Yes.
Yes, sir.
Yes, sir.
Is this giving us the answer?
Yes, sir. Answer
हाँ
आता है।
सर आ रहा है.
Same आता है.
Alright.
Yes, sir.
हाँ सर.
Now listen to the 4 important points. Previous case, you took the torque about point P without introducing pseudo force. Yes or no?
Yes, sir.
Yes.
sir.
Previous case में point P का acceleration was 0. देख लो,
Yes,
turn the
sir.
page and see. Previous case में the rod was horizontal. So this was L by 2 alpha. What is its component in the horizontal direction?
0.
So point P was not accelerating, which I was damn sure. So confidently I took the torque about point P and about center of mass, both gave me the same answer because point P was not
Accelerating.
If point P is accelerating, torque due to pseudo force acting on the center of mass is mandate, which I showed to you here.
Yes, sir.
So a standard textbook like a Halliday-Resnick or SL Looney or statics and dynamics by Einstein, none of them will tell you that you should take the torque only about center of mass. कहीं से भी लो, pseudo force मत बोलो, accelerating point भी ले लो, मगर एग्जामिनेशन हॉल में इतना रिसर्च थोड़ी करना है मुझे. So quite a few times they say take the torque only about the center of mass. यार center of mass भी accelerate कर रहा है ना यार, करने दो. Pseudo force ही तो डालना है आपको. कहां पर डालोगे? Center of mass पर डालोगे. Torque due to the pseudo force will become
0.
So remember 4 rules. I will first tell you the rules, then I dictate. First point. Preferably take the torque about center of mass of the body. माथा पेची नहीं रहेगा, problem is solved. तो सिर्फ एक ही rule बोल दो ना यार, always take the torque about center of mass, you are safe. There will be instances when I will have to shift away from center of mass. क्यों? क्यों भाई साहब? आपको can I rub this board?
Yes.
Yes, sir.
There will be instances when I will be forced to shift away from center of mass. Like There is a hinge this way and there is a thin rod. Hinge. Hinge force is like a nail inside a ring. I press it towards this, normal force is this way. I press it towards this, normal force is this way. Right? Hinge forces we will come to in the 6th lecture from now. Or probably next lecture I'll pull it ahead to complete this concept. Right? Hinge forces ka direction keeps changing. It will have an NX, it will have an NY. I don't know which direction it will be. So kya karu? Take the torque about the hinge. Now I will not take the torque about center of mass. Have a look. There are two forces passing through the hinge. What will be easy for me?
Torque about hinge.
Torque about the hinge. Am I eligible to take the torque about? I am now tempted to take the torque about the hinge because there are two forces passing through. Agreed. Are you eligible to take the torque about the hinge? Yes, because that point is not
Accelerating.
Suppose if that point is accelerating, a hinge कैसा accelerate करेगा यार? क्यों नहीं करेगा भाई? कल को एक ट्रक के ऊपर रख दूंगा और बोलूंगा ट्रक is accelerating. Now don't you think your hinge point is accelerating?
Yes,
It
sir.
is. Yes.
अब क्या करोगे? Pseudo force is
Pseudo force.
mandatory. M into A, M and mg के वजह से दोनों forces के वजह से torque lead. So first rule, preferably take the torque about center of mass. Second rule, you can take the torque about a point other than the center of mass as well. But confirm that the point is not
Accelerating.
By chance, if the point is accelerating, can I take the torque about the accelerating point? Yes.
Yes.
Provided
Pseudo force.
Pseudo force.
taking the torque due to pseudo force as well. All the conditions, are they clear?
Yes.
Yes.
Sir.
Now you know about which all points you can take the torque, right?
Yes.
First point, note. First point, likho. Preferably take the torque about center of mass of the body. Preferably take the torque about center of mass of the body. Preferably take the torque about center of mass of the body. लिखा है?
Yes, sir.
Yes, sir.
Yes, sir.
Second point, if not the center of mass, if not the center of mass, select a point which is not accelerating. If not the center of mass, select a point which is not accelerating. If not the center of mass, select a point which is not accelerating.
Yes, sir.
Yes, sir.
Third point, if the point is accelerating, if the point is accelerating, do take the torque due to
Pseudo
force.
do take the torque due to pseudo force as well. Last
Sir, can you
point.
repeat? Sir, please repeat the point.
What was the first word?
If
The point is accelerating.
If the point is accelerating, do take the torque due to pseudo force as well.
Yes, sir.
If the point is accelerating, do take the torque due to pseudo force as well. Last point. This pseudo force must be introduced on the center of mass of the body. This pseudo force should be introduced on the center of mass of the body. This pseudo force should be introduced on the center of mass of the body. Opposite to the direction of acceleration of this point. Opposite to the direction of acceleration of this point.
Sir, can you please repeat the second point?
If not
Somebody
the
else
center
not
of
the
mass,
center of mass, then choose
select
a
a point which is not
not
accelerating.
accelerating.
Okay, thank you.
Somebody typed
Can
all the
you
4
repeat
points
the
in the chat.
second last point?
Yeah.
If the point is accelerated.
Sorry, yes, sir. Tell the point. Do take the torque due to pseudo force after that.
बस
As well, बस
As
उतना ही।
well.
ऐसा सवाल था।
सर लिख के और टाइप करने कितने किसके पास इतना टाइम है?
पता नहीं किसी ने चारों पॉइंट्स टाइप करके भेजा है मुझे।
वो सिर्फ टाइप ही कर रहा होगा।
शायद नोट्स में ही नोट्स टाइप ही कर रहा है।
Sir, I was also one day writing on a note service online.
वाओ
डायग्राम
अरे वो पेंसिल
वो
से
तो
बना
थोड़ी
रहा था।
बनाएगा ये।
सबस्क्रिप्ट कैसे लिखता है तू?
अरे I was using the pencil.
It's okay.
Tablet.
बहुत झगड़ा करते हो। Now listen. Today we understood how to take the torque equation, about what all points you can take the torque equation. Is everybody crystal clear about this?
Yes.
Yes, sir.
Now this need to be learnt this way. First I would have dictated the rules and solved these two problems. Is one way of teaching. It will be generally that who pay concentration will learn it. Now everybody will remember this. First you make them commit the mistake and learn from the mistake, you will remember it. Hence I do the back calculation for this. Right?
Yes.
No textbook will tell you these rules because the textbook says take the torque about any point. Halideristic says take the torque about any point. Chalega for halideristic. Only thing, if the
Pseudo
point is
force.
accelerating, don't forget the pseudo force. That's all.
तो वो
He
लोग तो
will not
पूरा
present
सॉल्वेंट
it this way.
कैलकुलेटर से करते हैं ना, तो उनको तो क्या ही फर्क पड़ रहा है कैसे करो। वो हर चीज में लिखता है ये इक्वेशंस आ गई, अब कैलकुलेटर में डाल दो।
Halideristic नहीं।
यस सर, मैंने वॉकर ही पढ़ा है बट उसमें वही करते हैं।
हाँ सर, वॉकर ही मिला।
Committing a mistake is not a mistake. Not learning from that mistake is a
Blunder.
Sir, are you going to help us today in maths? अरे यार करेगा।
papers
सर
are
अभी आप
not
हेल्प
the
मत
same.
करो।
Question papers hell of confusion create होता है. No. Maths you are on your own. Ask GKM sir.
सर कुछ चैप्टर्स भी नहीं है सर।
खुद ही कर लेंगे
GKM सर ने कमरा कर दिया है।
ये तो मैथ है सर, ये बोलना ही मतलब शर्म है कि पूछते हो।
हाँ सर।
हाँ सर।
वैसे भी जीकेएम सर हमें उड़ा देंगे, जरूरत नहीं।
रुको। Now I'll stop here. I'll go back to doubts of conservation of moment.
सर एक्सरसाइज 3 ना।
शो बोलेंगे अभी सेकंड, मुझे भी बुकलेट खोलने
2
दो।
and 3.
बुकलेट। EMI AC magnetism, electrostatics.
सर अचानक डाउट्स क्यों?
They're leftover.
सर मैं बोला था वो लास्ट में डाउट्स होंगे.
Last 2 lectures से we were thinking last में we will take. हाँ बोलो कहाँ से? Exercise 2.
Exercise 3.
Sir, exercise 3.
3.
Passage 6.
Passage.
Passage
6.
That's all.
Sir, एक second, sir.
Passage 4.
Passage 4. Sir,
Sir,
passage
11.
Passage 11.
No, sir,
Question.
11 question only.
वो कौन सा पैसेज में आ रहा है?
Passage 2.
Sir, वो तो
Sir, class
में
notes.
Sir, class notes में है वो बहुत डिटेल में.
Sir, वो रुड़की वाला.
That रुड़की वाला question.
हाँ एक रुड़की वाला क्वेश्चन है.
सर तीनों है वो भी.
Passage 4.
सर बस पैसेज 3 का 15 क्वेश्चन.
Passage 3.
इसमें 15.
Passage 3. One particle, 1 kg mass moving along the positive x-axis with a velocity of 1 kg mass, 3 meters per second. Another particle of mass 2 kg moving along the y-axis with a velocity of moving along positive y-axis. Time t equal 1 kg mass is at 3 meters, 0.
Yes.
This is 3, 0. 3, 0 पर क्या है?
तो 1 kg mass का वो नहीं सर.
1 kg mass moving in this direction with 3 meters per second.
Yes.
And 2 kg mass at 0,9. 2 kg mass at 0,9. 0,9. Here I have got that 2 kg mass moving with how much velocity? 6 meters per second. 6 meters per second. Right? Another particle of mass 2 kg moving along the y direction with velocity 6 meters per second at time t equal to 0, 1 kg mass exact. 3,0,9 xy plane horizontal rough for questions 14 and 15.
Yes,
These two decent. Center of mass of the two particles moving in a straight line. That all of you would do. Coordinate geometry कहाँ तक हुआ है? Straight lines हो गया?
हाँ सर.
हाँ सर.
Both that question, 13th question is rocket science for students for whom coordinate geometry is not that. They feel so very complex with it. Now, if both the particles have the same value of coefficient of friction, the center of mass will stop at time. Okay, that can be done, not an issue. Coordinates of center of mass, where it will stop finally are. And the velocity of center of mass. Now, friction mu is given. The problem is both of them need not come to rest simultaneously, right?
Yes.
Yes, sir.
So coordinates of center of mass where it finally stops.
Yes, sir.
Now, find out where will this stop, where will this stop. Where will this stop? Mu कितना दिया हुआ है?
Mu
0.2.
0.2. So mu g is the acceleration. S is equal to v square is equal to u square plus 2as. V square is equal to u square minus 2as. Final velocity is 0. 3 square minus 2 into mu g into sx. Sx is 9 by 2 into 0.2 into 10. 9 by 4. Sx will be, this will move a distance of 9 by 4. 9 by 4 is how much? 9 by 4 divided by
2.25.
0.25.
So 3 plus 2.25 is
5.25.
5.25 meters. This particle will come to rest. Similarly, find out where this particle will come to rest. Final coordinates of center of mass आ जाएगा कि नहीं?
Yes, sir.
ठीक है सर. Yes, sir.
सर पैसेज 5 का क्वेश्चन 21 भी ले सकते हो.
Passage 5. Momentum
Question
of both the
21.
blocks are equal in time equal to है. So you know the final velocity. Momentum कंजर्व कर सकते हो. Final velocity आएगा कि नहीं?
Yes, sir.
Initial velocity पता है आपको 1 kg ब्लॉक का.
Yes, sir.
उस पर फ्रिक्शन का वैल्यू पता है आपको.
Yes, sir.
तो टाइम आ गया कि नहीं? V
हाँ,
equal to
yes,
plus
sir.
18. फाइनल
हाँ,
मोमेंटम से फाइनल वेलोसिटी आ गया. इनिशियल
हाँ,
वेलोसिटी पता है, फ्रिक्शन पता है. V equal to plus 18.
okay, sir. Okay, sir. Thank you, sir.
Passage 4. Passage 4. A cracker is thrown up into air. Passage 4. Passage 4. A cracker is thrown up into air with a velocity of 10 meters per second and at an angle of 45 degree. 10 meters per second at an angle of 45 degree. Range will be maximum. When it is at a height of half meter from the ground, it explodes into number of pieces which follow different parabolic paths. Number of pieces. कितना pieces बोला है?
नहीं, sir.
What is the velocity of center of mass when it is a height of 1 meter from the ground? Okay. Velocity of center of mass. Calculate the velocity of the projectile. It will be the same.
Yes, sir. It follows the
Other than
same path.
gravity, there is nothing else acting on it, right?
Yes, sir.
So because of gravity, see, it may explode into n number of pieces, but the projectile center of mass will go in the same path. That is the key catch. Yes or no?
Yes.
Yes.
So 16th question mein, what is the velocity of center of mass when it is at a height of 1 meter? What would be the velocity of the projectile when it is at a height of 1 meter? Will be the velocity of center of mass.
Yes, sir.
What is the time taken by the center of mass to hit the ground? Nothing will change. Time taken will be the same. Time of flight. Maximum velocity of center of mass in its path.
Sir, minimum.
Minimum.
Minimum velocity.
Minimum.
Yes, sir. Minimum.
This is human bias. How did I read minimum as maximum?
तो वो easy होगा.
Sir, in your TED Talk speech also, you had said that you took that graph by mistake because you were used to taking it that.
Now, very frequently, this bias is more with me because regularly I keep teaching something which will be in the subconscious mind. So maximum अगर दिमाग में है तो we will see minimum also as maximum. That's a mistake which we consider a silly mistake in the exam. That's not silly. It is bias, conditioning of the mind. What is the minimum velocity of center of mass in its path? When will the velocity be minimum at the topmost point?
Yes, sir.
You
Only
cos
horizontal.
ये तो pure projectile है. इसमें collisions introduce करके is trying to confuse you. Nothing will change as far as the projectile motion is concerned. Because for everything he is asking the center of mass. Center of mass will continue in the same path.
Yes, sir.
Because there is only one force called gravity. So whatever is the influence of gravity, it continues in that way.
Yes, sir.
Now, passage 6, we actually messed up with this. Technically, I'll tell you what is the mistake that we have committed here so that you will know what the mistake is. This is small and this is capital. थोड़ा ध्यान से सुनिए. Where we went wrong with whole of this is, we tried to change the question. Two faculty members changed the question and both introduced simultaneously. The typist did not confirm with both the faculty. One did one change to make the question correct. Another did another change to make the question correct, which both are not in sync. So that way we screwed up with whole of this question. But the science behind is like this, watch out. Technically, when this comes over this point, what was the necessity for you to make this curve smooth? You will understand that in this chapter, rotational dynamics, we will deal with this separate. At length, I will tell you, because when a mass comes and hits this, at this point, there will be an impulsive force. If I take a triangle like this, and I tell you I gave velocity to this, when this collides at this particular point, that collision will be
Impulse.
So directly you conserving momentum is wrong. So the faculty thought to avoid that controversy, we will make it smooth.
Yes, sir.
But even then there will be collision. That's the wrong. He is just trying to soothe the effect there, but yet it is wrong. Right? Even then it will collide and there will be an impulsive force here. You cannot directly conserve momentum all throughout. Second mistake. In constraints, what did you tell me? When can I conserve momentum along x-axis? When the masses came this way, I will take Vx this way. These both.
Yes. Yes,
right?
sir.
And this, from where did you conclude Newton's laws ka constraints? Recollect, perpendicular to the common area, both should have the same velocity.
Yes.
So if the diagram would have been this is u, small mu is equal to small m plus capital M into Vx. This makes sense?
Yes, sir.
Yes.
Right? And we solved such a problem in the class.
Yes.
Now, the last shape, uppermost point of this particular diagram goes this way. That means when it is leaving contact, I cannot take velocity along x-axis to be conserved. Perpendicular to the common area, this velocity for both will be the same, not the horizontal velocity. इसको इस डायरेक्शन में रिजॉल्व करके ही मोमेंटम कंजर्व कर सकते. क्यों? इस डायरेक्शन में कंजर्व कर दो ना. इस डायरेक्शन में कंजर्व कर दो ना.
External forces.
What is the external?
What?
What is the external?
Normal force.
Normal force is internal for both of them.
Gravity.
And here gravity is not limit delta t tending to 0, it is climbing all throughout.
Oh.
Gravity is non-impulsive, but who told you delta t tends to 0? Delta t is not tending to 0, it is climbing from here till here, right? Gravity produces substantial change in momentum. You trying to conserve momentum in this direction here does not make sense. Taking this velocity, resolving it in this particular direction.
Yes, sir.
Right? So fundamentally, there are three mistakes in this question. Learn from mistakes. Right? Firstly, making this a smooth curve does not solve our problem completely. Right?
Yes.
We will have to take conservation of angular momentum about this point.
Yes.
So this mass should not collide with this. This mass should not. This is a separate triangle. That's where the whole of the problem comes. Give me one wedge kept this way and keep it here. Now I have no problem because normal force becomes an internal force. Right? Second most important thing, let the mass come here. In this direction, I can conserve linear momentum in the horizontal direction. All throughout in the horizontal direction, gravity doesn't produce any external force. It's in the vertical direction. Right? Hence, these answers don't match for you. Specifically, the 24th answer doesn't match. We messed up with those values. Last year also, I thought I'll make the correction, but somehow it slipped off my mind. The values need to be changed. The uppermost point shape need to be changed. Last point and the most important. This is Vy, this is Vx. The angle at which it will be projected is tan theta is Vy by Vx. Tan theta is Vy by Vx. He gave you in the question angle at which it leaves. Angle at which it leaves will not be the shape of the slope of the curve. Wrong? Now here shape is vertical. Shall I tell you that the particle has only vertical direction? No, it has horizontal as well. So angle at which the projectile goes is tan theta is Vy by Vx. Whatever may be the situation. Now you take this way. Call this Vy, call this Vx. It goes this way. So tan theta with the horizontal will be Vy by Vx. Remove this completely. This tan theta will be Vy by Vx. What is the angle at which it leaves contact with the surface? That angle will be tan theta is Vy by Vx. Is this point clear?
Yes, sir.
3 points I summarize. Listen. Firstly, collision at this point cannot be ignored. Chalo, we ignored it. That doesn't change the answer. Second, the shape of the curve here will insist that I will have common velocity in this direction. अगर आपको वहां का आंसर आना है तो this velocity को इस डायरेक्शन में रिजॉल्व करके कंजर्वेशन ऑफ मोमेंटम अप्लाई कर दो. अगर आपको वहां का आंसर आना है इस वेलोसिटी को हॉरिजॉन्टल डायरेक्शन में रिजॉल्व करके कंजर्व द मोमेंटम. राइट? But yet there is a conceptual mistake in it. Taking the same velocity in this direction is mandate. Last but not the least, angle at which it is projected will not be the slope of the curve there. It will be tan theta is Vy by Vx. Angle at which it is projected is not slope of the curve. Right? So now, how do I resolve this in this direction? I don't have a scope. That value is not given. That slope of the line is not given. How do I resolve this in this direction? Slope of that line is not given. So I cannot conserve moment. So I am handicapped there whether the number of equations are not equal.
तो वो जो 60 डिग्री नीचे दिया है उसको या apparently ऊपर उसको
Of what use is that, you tell me? This 60 degree, can I consider this to be equal to 60 degree?
No. सर कर नहीं सकते बट वरना तो वो 60 यूजलेस है तो यहाँ पर ही यूज कर ले.
And वरना none of the answers match. So firstly, you understood what are the mistakes in that particular paragraph?
Yes, sir.
Yes,
Yes, sir.
I'll make changes in that paragraph this year so that at least your juniors will be
Happy.
happy. Committing a mistake is not a mistake. Not rectifying is a blunder. That's a blunder from our side.
इसको 3-4 बार करके एक किसी अटेम्प्ट में तो आंसर्स मैच कर लिए थे बट आइदर में छोड़ दे रहा है ना.
24 का नहीं मैच हो रहा था. 22 23 हो जाता.
मेरे सारे हो गए इवेंचुअली.
22 23 मैच हो जाएगा. 24th नहीं होता.
हाँ सर वैसे ही कुछ हुआ था.
Sir, even after
तो
result,
JH by JV tan 60 ले लिया तो हो गया.
22 भी दिखा सकते हैं.
Okay, now listen. Next class will be equally important. Today's class on rotation, you understood why this is so important.
Yes, sir.
Without which you cannot proceed with any torque equation. Fundamental torque equation apply nahi kar pao. Next class I will be gradually going into connected bodies. There will be n number of problems I solve on torque equation for the next 3 lectures. Translational dynamic equation, rotational dynamic equation, constraint relations. This will continue for next 3 to 4 lectures. Only then you'll have homework.
Okay, sir.
By then, please complete the balance homework of whatever it is, conservation of momentum or rotational dynamics. Next
Yes,
class
sir.
also last half an hour I'll take doubts. I'll finish exercise 2 of conservation of momentum. Then I'll come to rotation, exercise 1, moment of inertia problems.
Yes, sir.
Can you send the rotation booklet on the group?
In fact, last class also you people asked me.
Yes, sir.
Where I'll send.
Sir, so what should we do about this question? Like, should we resolve it that way or should we just leave the question?
Just leave the question. I'll make the rectification later on. You can see.
Okay, so we'll just leave the question.
Thank you.
Thank you, sir.
See you people in the next class. Wish you all a happy weekend.
Thank
All
you,
the best
sir.
for the evening's exam.
Thank you, sir.
Thank you.
Which exam? Acha college.
Thank you, sir.